Okay, welcome back everyone to episode 2. If you watched the last episode, you know I started on a new project, which is the cornhole boards. So before we get back out in the shop and finish up with those box joints, I thought I'd show you a little bit of the design parameters of the cornhole boards and some of the features they're going to have. So I'll switch you over here to the computer screen that I do my CAD work on, and I'll narrate a little bit about some of those features. So stand by here. Okay, so you should be able to see a side view here of the cornhole boards. You can see here there's the box joints that we're doing. This line represents basically the ground. So with this kicker leg or support leg folded out, it sets it at the correct angle. So that gives you a kind of a side view of what it will look like on the ground. This second view here, this is just simply with it rotated and the main frame on a straight plane. I did that for taking some measurements. And then this third view here, that has a little bit more stuff going on that'll kind of help depict the design. And some of that is, you see these circles here, what those are going to be the black walnut dowels that will tie the sides to the tops. They'll be the top will be recessed in a rabbet, so it's fully supported anyway, but that'll kind of lock it in there really good and give it a little bit of some highlights. This piece here, that's just a supporting cross member that helps keep the top from bowing. This red line, that I think that's probably going to end up being a biscuit. I haven't decided how I'll attach those to the side. Because this board would be in grain, it won't glue very well to the long grain of the side frames. I thought about doweling them, but then there would be a dowel here kind of it would look a little odd, I think. So I'll probably do this with a biscuit, which you wouldn't see. I may do a 10 and 2, I haven't decided. This just depicts a handhold, so you'll be able to, once they're folded up, you'll kind of be able to carry them like a suitcase. Here is another cross member. This is just the leg folded. If I select that, you can see that I can fold it down, and so that would go into the position where it would support it. Undo that. This piece here, depicted by the dotted line with two circles, that's a stretcher that will go between the two legs. Those two circles also depict dowels. So this is just shows those legs. On that stretcher piece here, this dotted line here, that stretcher piece, this view is from those on the top, so it shows their rough shape. These circles depict, those will be cup holders. So if you happen to be playing a game and you have whatever your choice of beverages and you don't want to set it on the ground, there'll be some actual cup holders that, when folded, you can see here, those, in essence, those cup holders would be right here. If I give you just a real quick square, those would be sitting in here approximately, and then that lets you set your beverage can in there while you're playing the game. So anyway, that gives you a quick once over of some of the design features. One of the reasons why, of course, you could do this without a CAD drawing. It's not that complicated of a thing, but one advantage to it is it kind of lets you think through which operations you're going to do in what order, because sometimes you can snooker yourself if you do the wrong thing. Like if I glued this up before I did the dado, it makes it a little bit tougher. You could do the dado still probably with a router at that point, but so I like doing the drawings, and that way it helps me kind of think through what the order of operations that I'm going to do this stuff in. So anyway, that gives you a quick overview. Let's get back out to the shop and finish up the box joints on the long pieces.
One other advantage of a box joint, just so I'd show you, is if you're going to do a joint that, let's say, is a butt joint or dowels or dominoes or biscuits, if you look at it from this direction, you have to take into account whatever your overall lengths are. You have to take into account the thickness and subtract that, so you always have to keep that in your mind with a box joint, because every other pin goes full length or full depth, whatever your dimensions are. In this case, 24 by 48. That's the actual dimension of both sides. You don't ever have to compensate for the thickness because it goes all the way through. Anyway, I'll set you back here and we'll get going on them. The 48 inchers, those are a little bit harder because you have to stand the board on end. So it slows the process down, but I'll probably clamp those each time. And that way there's no chance that that board can wiggle a little bit when I'm pushing it through the blade and mess the joint up. I'm also, I think, going to put a magnetic stop on the table. Not that you can't really go too far, but I've got a block on the backside. Not that you ever have your hands down there, but I've got a block on the backside of this to keep so as the blade comes through, you couldn't accidentally touch it, and to keep from blowing all the way through the back of that. I'll probably put a stop on the table. Thought I had two of those, I guess I don't. You do need to, well, you wouldn't, I guess, have to, but so that things are symmetrical. And let's say that on this sample fleece, let's say this board is going to be the front. That pin's on top, so you do want to be thinking about when you're cutting these, and that on this other end over here, that you also set it up on there to where the pin is at the top. It would work without it, but from a symmetrical standpoint, if you look at this, and the pins are offset by one, it might look a little funny. Down. All right, there's all four of the short pieces done. We gotta grab a clamp here and get set up to do the long ones, and be right back. Okay, so I've got the box joints cut on all the short pieces. I'll pan you down here. I put them together just even though the end pieces don't all go together, and basically that creates a box. So they lined up good, looks nice. Clearances are nice and tight, or gaps are nice and tight. So I'm going to move on to cutting the box joints on the long pieces. I probably will just skip past filming that because the process is no different than what you already saw on the short pieces. The only difference being, since they're 4 foot tall, they're a little more, have a tendency to be a little more tippy. So I'll just clamp them to the sled each time I run them through the saw. So let me get those cut, and then I'll bring you back and we'll talk about some of the other cuts and dados I have to do on those before I glue them up as an assembly and dry fit them. So stand by here and I'll be back in a minute. Okay, so now that all of the box joints are cut in the short and long pieces, you can see here, I'm going to work on the rabbet so the top will set down and recess. So I did a little layout and ran one piece through. I'll show you here. So this piece here has got a rabbet cut in it. And then ultimately when they go together, that will create a recess. The problem is doing it on the table saw, which I prefer to do because of the curvature of the blade. I'll have to work these corners by hand. If this was, for instance, a butt joint, I could, on the one piece that's cut, if this piece was the butt joint piece and this was the long piece, I could cut the dado or the rabbet all the way through because this would hide it. But since it's not, it's a box joint and these fingers are only 3/8 of an inch thick, and I'm going to make the dado needs to, or the rabbet needs to be 1/2 inch deep, it would end up taking away part of this pin, and you'd see this, there would be a hole right in here in this portion. So I've just got to stop short on all of them. And then I will clean those up either later with a chisel or maybe do a little bit of work with the router. So to keep from running long and ruining the piece, in fact, I'll show you a sample here of what. When I was doing the setup on my scraps or my samples here, I wasn't concerned about going through too far because they're just pieces for setup. So on this one, I did run the rabbet all the way through, so you can kind of see here what happens when I assemble it. Looks good from this direction, but as soon as you go this way, you end up with this hole, which obviously is not good. So you have to stop that rabbet short, and I just figured out where I needed it to stop. And I made some marks on the fence. So when I run it through here, I just bring the board to the end of the purple line, and then as I transition through, I stop this in when it also reaches that line. So that keeps me from overcutting. I just left the dado stack in. I set it I snuck up on it, and in essence it's right at 1/2 inch deep, which when I go to add the 1/2 inch MDF, it makes the MDF perfectly flush with the top of the sideboard. So this will be the top, it'll get covered with the skin, so all you'll see is the maple. So I set the table saw, or set the saw blade 1/2 inch deep, and then the width didn't really matter. It's about almost 300 thousandths, so a little over 1/4 inch. That doesn't really matter. It's just the ledge that it sets on. So the fence is set to where that gives this much, takes that much material out. So I'm going to go ahead and run these all through, and then that will get that step done. And then we'll figure out how I'm going to trim out that extra little bit. When you're doing things like this, I mean, you wouldn't have to. I do, because it would be really easy to lose track of which edge you're supposed to be cutting on, which side goes to the fence. So I always make marks on all the wood that shows me what the waste portion is, so that I don't run the risk of accidentally cutting wrong. Since the 4-foots are a little bit longer and not quite as easy to manipulate, I think I'll go ahead and set up a couple feather boards to help hold it tight against the fence. Even if it moved a little bit, the only effect it would have is if this amount right here could vary a little bit. It doesn't really matter because that's going to get covered with the skin. So when I cut the top, I'll cut it with a little bit of clearance anyway. So it's really not that critical. Okay, I'll tip you down here where you can see I've got those set up to where those will help keep those longer pieces tight against the fence. They're not so tight. They're not holding the board so tight though that I can't slide it backwards, because as I bring it down onto the saw, I need to bring it down and scoot it back a little bit. So I'm just adjusting that to where it'll still let me do that. Alright, let me stick two of these together, and then I'll give you a close-up so you can see that. Okay, you can see here, you can see the rabbet here, and then the rabbet here, and you can see that they don't join, and if I change the angle, you'll see that there's the curvature of the blade. So I'll just need to continue this line out and notch it into the depth the other one is at. I'll bring it back here once I've decided how I'm going to accomplish that. If I do it with the router table, I'll bring it back and show you the setup on that. If not, it's just a matter of breaking out some sharp chisels and doing a little bit of chisel work. Okay, so I tried a couple different ways of finishing out that corner on the side pieces. Don't remember if I showed a close-up or not, but I think I did. But when I do that rabbet with the table saw, it leaves this curvature of the blade because I couldn't run all the way out the end. So The first one I did with the chisel, and it came out okay. It's squared up there. But you're doing a lot of, especially trying to shear this end grain, I'm having to, you know, it's hard maple, so you got to pound pretty hard. So I'm a little worried about cracking, or, I mean, this one came out okay, but I'm a little bit worried about hurting that pin or cracking that pin. So I did decide to go ahead and set up the router table and do it with the router. So I did one just to make sure it was going to work, and it finishes that out. Except for it does leave, of course, the radius of the cutter itself, or the bit itself. But that's no biggie, because when I cut the top, I can just put that same radius on the corner of the top and it'll drop down in there. So I'm gonna scoot you down here. This is, I don't have a fancy purchased router table with a top side height adjustment. It's kind of an old school table. You still have to adjust the router from underneath, but it gets the job done. So the back side, what I did here is I just put a couple the same as on the table saw. I put a couple witness marks on the fence. So when I'm moving the board back, I know those witness marks line up with the end, so I know when to stop, and that way I don't overcut it. And I did a witness mark on each side. The right-hand side is pretty easy because that's a conventional cut or milling direction. But when I have to go backwards the other way, that's a climb cut, which if you're making a really, really light cut, it's not the end of the world. But if you're making a heavier cut, that's when the router bit is going to, because it's a climb cut, it wants to grab the material and take off with it. So you just got to be really, really careful. I found instead of feeding into it or coming in up against the fence and then feeding this direction into the bit, it's easier to set my distance where I want it to be, hinge back on this far side, and then bring it into the cutter, and that way this end's stable. So I would basically do this operation here. I can eyeball where the end of the board will be in relation to the, I'll scooch you over here, you might be able to see it better. I can just eyeball the end of the board in relation to that witness mark, and then I can plunge into that and then conventional cut on the way out to keep it from grabbing it. So I'll make one cut here on camera just so you can see it, and then it'll just be a matter of doing it 8 more times. You probably don't need to see that, so I'll film the first one and then we'll see how it goes. Let me grab some hearing protection. So that works just fine that way. That I might check, and actually I was gonna see if I had a little bit sharper carbide bit, but that setup's already done on that one because it's burning the wood just a little bit, but nobody will see it. It'll be in an area that's hidden. So that's the first end, and that's the second end. So again, you probably don't need to see me do this 8 times, so I will bring you back once I've got that done, and we'll talk about how I'm going to attach the support stretchers underneath. Okay, I got all 8 of those cut. Let me bring you over here so you can kind of visualize. It's sometimes hard to visualize maybe some of the things I'm talking about. So this one's just dry fit, so you can see how it finishes out that corner. Other than this portion here, that little radius, I'll have to put that on the top that goes in there, but that's no biggie at all. So let me get some stuff laid out here, and then we'll talk about the spreaders. Okay, so I thought about it some, and I decided on those spreader pieces or support pieces, cross members, whatever you want to call them, that'll help support the top. I decided to attach those to the sides. Instead of using a biscuit, I'm going to go ahead and do a mortise and tenon on them. So I'll bring you down here. So I measured out, I went back and looked at the CAD drawing, figured out where they needed to be. I couldn't quite divide them in thirds because the folding legs need to be able to fold up in there. And if the true thirds, the leg would have just caught it down here on this end. So it's really close to being divided into thirds. So I've got them laid out here, as you can see. It'll be this outside line. Let's see if I can get you a little bit closer here. Okay, so I've got them laid out here. This outside line just depicts the 3/4 inch wide by 1.5 inch tall spreader that's going to be there. Then the hash mark section, that'll be actually the mortise. So I'm going to use a pattern following bit in the router. So I'll just cut out a piece of MDF that has that exact mortise shape into it. And then I'll clamp that to each board and remove that material with that pattern following bit. So I'll get that set up and then show you what that looks like and how it's going to work. Okay, so I'm ready to cut these. Here's the piece I cut out. Basically, since I had the dado stack still set up, I'll just swing you over here. All I did was use the dado stack and the box joint jig, reset the saw height, held it up there. This was wider than the dado stack, so I just made 2 passes to make a nice squared out notch. Swing it back around here. So then this simply clamps on here. There's enough room. This is wide enough that I can get a couple clamps on there and still have room to move the router. Basically, the pattern following bit is pretty much this size. It worked out well because I wanted I think that's a 1/2 inch mortise. Measure that. Yeah, that's a 1/2 inch mortise. So that pattern following bit is a 1/2 inch flat bottom cutting bit with a 1/2 inch bearing on it. So it just basically, I don't even have to follow the perimeter of this. I just plunged in and bring it back out. So it works. I just line it up. I made it to where this edge, I run this edge parallel or flush with the rabbet right here. Clamp it and then plunge the router in and out, and then that's done. The reason why typically I do the mortise first, because you're usually dealing with either a fixed router bit diameter, or if you're going to do it with a dado stack or whatever, that's a fixed width. Then when I cut the tenons and I cut the shoulders and remove material off the shoulders, you can customize how much you take off to make a nice snug fit. So I typically cut the mortise first, and then when I show you cutting the tenons on the spreader bars, then I'll show you how I kind of sneak up on that to get the fit that I want. So let's get these cut.
A few moments later.
Okay, so that wasn't too bad. Got those all cut. Pretty straightforward operation. So I laid out the maple I have left over here, and I've got to get, there you can see it, I've got to get the stretcher pieces, or the cross pieces that we were just talking about, out of that. I've also got to get the 4 legs out of it, and then the stretchers for the legs that have the drink holders or the cup holders in them. So there's enough wood here, but I guess it was a good example, or a good time to kind of talk about the efficient use of materials. And for anyone that does woodworking knows that the wood can be very expensive depending on what species it is, and so you try to get use it as efficiently as you can. So that's one more area where I prefer to use the computer, because it really helps in that aspect. You could certainly measure things out and try to lay it out, but I kind of want to swing you around here and show you what I'm talking about. So when I have wood in any given project, I'll even use the same principles with steel. I'll draw up in CAD whatever the shape and size of that wood is, and then I also have my actual milled pieces, or my finished pieces, and so I can have the ability to drag them and drop them on top of each one of the boards. So what I mean, so this printout is of the remaining pieces of wood I have left. These 2 here on the right, they're over on a different spot on the saw. So basically what you're looking at is these 3 boards I just panned back and showed you. And so I put those in CAD based on their actual sizes. And then I can, as you can see, so those would be the black lines, and then the red lines are the pieces that I actually need to cut. So I have the two stretchers here and here with the cup holders in them. I have the 4 cross pieces that we're working on now with the tenons that will help support the top, and then I have the 4 legs that you can see there. So it gives me the ability to kind of figure out what's the most efficient way to use the material so that there's little scrap, and that so you don't have to go buy potentially more material if you just happen to didn't think through the best way to efficiently use it. So anyway, I noticed that I've got quite a bit of footage here, and after editing, I'm guessing I'll be a little bit north of 30 minutes. So this is a good spot, I think, to close out this episode and bring it back next Friday, where for sure I'll be able to get these pieces cut to length, get the tenons put on. I anticipate should be able to get the handholds cut and probably start some glue up. So appreciate you watching Build It or Buy It, and you guys know what to do at the end of the video to help me out. Thanks.